All right, good morning or good afternoon, whenever you're listening to this. So you have some practice problems to do here. You have one that say multiplication, power to a power. And then this one has more practice using power property. And on top of that worksheet, on top of the answer key, you'll see it says mix there. But find this worksheet. I'm going to work through some of these problems here, just because this gives a mix of the multiplication and the division and power to power rule. All right, so I'm going to do a few of these on here. And if you notice on the answer key that's posted online, some of them are circled. So it's number 7 circled, so I'm going to do number 7. I think these are some past problems that students have had problems with in the past. So let's take a look at these. All right, so I got a good problem here with the negative on the outside. And 6 is a problem with the negative on the inside. So how about we bang both of those out and see what the difference is. All right, so negative on the outside really just means negative 1 times the 5x to the 4th, all raised to the 2nd power, right? So I'm going to leave that negative 1. I'm going to kind of forget about it for a second, but leave it there on the side. All right, and then I'm going to square the 5, and I'm going to have 5 squared, and then I have x to the 4th, and this is a power to a power, so I'm going to multiply that exponent by 2. So I'll have the negative 1 times 5 squared, which is 25, and x to the 4th times 2 is x to the 8th, and this will give me a negative 1 times 25, which is negative 25, x to the 8th. All right, and now let's look at and compare number 6. All right, so the negative is on the inside, so this is, I'm going to write negative 5 to the 3rd power, and this is a to the 3rd times 3. So I'm applying that exponent to both of these, right? So negative 5 to the 3rd power means negative 5 times negative 5 times negative 5, right? So you have the exponent being cubed to an odd power, so it's going to stay negative. 5 times 5 is 25, times 5 is 125, so you get negative 125 out of that. And a to 3 times 3 is just a to the 9th power. All right, so hopefully we can recognize the difference of when the negative's on the inside versus when the negative's on the outside. All right, I'm going to screen forward, and I have another example here I was going to do number 13 here. Cool. We got the negative on the inside and the negative on the outside. Love it. So this negative on the outside, this is really negative 1 times, right? And then I have that negative 3 on the inside to the 3rd power. So I'm giving that negative 3 to, I'm giving that 3rd power to negative 3. Then I have a squared, I'm going to multiply that by 3 as well. And then I have b, which is by itself, so it's really just b to the 1st times 3. Right, so I'm multiplying all the exponents in the inside of parentheses. This is negative 3 to the 1st. By 3, and then this negative 1 on the outside. So negative 1 on the outside still stays. I'm going to leave that alone for a second, right? Because I want to do all my exponents first. So I have negative 3 to the 3rd power, which means negative 3 times negative 3 times negative 3, and that's going to remain as a negative 27. Then I have a squared times 3, which is going to be a to the 6th, and then b to the 1st times 3, which will just be b to the 3rd. Right? You don't have to write b to the 1st, especially if there's nothing there, but I'm just going to write it there for visual there. And then I have negative 1 times negative 27 is positive 27. a to the 6th stays as a to the 6th, and b to the 3rd stays as b to the 3rd. So I have 27, a to the 6th, b to the 3rd, which means 27 times a to the 6th power times b to the 3rd power. Right? So if I have numbers for a and b, I can plug them in and get some answers at some point. All right, cool. So you have negative z to the 9th power, and negative z to the 3rd power, to the 6th power. I like number 14. Just recognize that you have the common base of negative z. So cool. Where do I have a negative z? Well, this is just your base is negative z. So I'm going to get rid of that. So I have negative z, and I'm going to take 6 away from the bottom, take 6 away from the top, and that's going to leave me with 3 of them. And then again, the negative power is going to remain negative, and z to the 3rd is just going to be z to the 3rd. All right, that's number 14. Let's see what else is on here. 18. 18 is cool. So really looking at 18 for a second here, right? So we have 2x squared and parentheses. So this 2x squared is in parentheses. Right, I'm going to ignore this for a second. And there's nothing up, there's no exponent here, so there's an imaginary 1 here. There's no coefficient in front, so it really there's an imaginary 1 there. So really, this is just 2x squared, and I don't have to do anything else to that, right? That's just 2x squared. But I am going to multiply by 2x to the fourth, which means I'm going to take 2 and raise that to the fourth power times, and I'm going to take x and raise that to the fourth power. And then I'm going to simplify, so I have 2 times x squared times 2 to the fourth, which is 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, and then times x to the fourth. 2 times 16 is 32 most days, and x squared times x to the fourth is x to the sixth by rules of multiplication. A couple more here. Let's see what else we got. Let me see if I make this a little bit bigger. Lock this. Sure, perfect. All right. All right, and then we can lock this again. Okay, so now we got number 19 here. Similar example. Okay, 3c squared times 3c cubed. All right, so you could do this a couple different ways. All right, and the easiest way I'm hoping you guys can recognize is your base is 3c. Right, so your 3c is your base, and you have. So if you imagine this as this was just x squared times x cubed, then you would just add these two exponents, right? And you have to the fifth power, right? But just recognize that 3c is your base, so it's 3c squared times 3c cubed, which is 3c to the fifth. And now, once you're here, then you got to do a little bit more work, and you have 3 to the fifth power here, and that's going to be, so 3 to the fifth times c to the fifth, and that's just going to give you 243 c to the fifth. Alright, what else we got here? I think we just did number 19. That was one of the circled ones in that packet. 25 looks like it might have given students a challenge in the past. So let's look at 25. Alright, so we got this whole expression in the parentheses raised to an exponent and negative x y to the squared raised to an exponent as well. So let's tackle these one at a time. So I got 2 to the fourth power. Cool. I'm going to take that to the fourth power. And again, I'm writing this out. If you can do this mentally right now, it's not a bad idea. But I'm just going to keep writing them out until you get more comfortable. X squared to the fourth power. So I'm going to multiply that one by 4. And then I have y cubed to the third power, which I'm also going to multiply by 4. So if I just go right along and simplify this, I got 2, 4, 8, 16. X to the 2 times 4 is 8. 3 times 4 is 12. So that simplifies all that one. And then, so times, and then let's take care of this one now. So I have the negative sign. So I have, if I want to think about it, I have negative 1 squared times x squared, and times, I already have y squared, so I have to multiply that exponent by 2. Simplify all this. Negative 1 times negative 1 is just 1. I'll just write down for visuals. X squared and y squared times, so y 2 times 2, and I get y to the fourth power. So now I have 16 times 1, which is just 16. X to the 8th times x squared. Add the exponents, I get x to the 10th. And then lastly, I have y to the 12th and y to the 4th, and I get y to the 16th. Alright, and then there's definitely a lot more in here. Let's do one more fraction. Why not? Let's do 26 while we're at it. We have 1/3 to third power, so 1/2 to third means 1/2 times 1/2 times 1/2. So 1 times 1 times 1 is 1, and 2 times 2 is 4, times 2 is 8, so that's really just 1/8. P squared to the third power, so I'm going to multiply p, and I'm going to multiply 2 times 3 and get p to the 6th. And then this is q to the first to the third power, which is just going to be q to the third. So I went a little faster on this one, right? So I'm not rewriting them all like I did on number 25. I'm just going to try to do the multiplication up front. 2 to the fifth power, so 2 times 2 is 4, 8. So we got 2 times 2 is 4, 8, 16, 32 times 32. And then y to the fifth is just y to the fifth. All right, then I consolidate 1/8 times 32 is the same thing as saying 32 divided by 8, which is 4. I don't have any more p's in there, so p to the 6th stays as p to the 6th. Q to the 3rd stays as q to the 3rd, and y to the 5th stays as y to the 5th. And again, the order of this p, q, y doesn't matter. Alright, so let's continue page forward and see what else is there. If there's any other ones that are interesting on here that could be fun. 32 looks fun, so let's hit that one up. So you got parentheses and brackets, right? So brackets are just another form of parentheses. It's just when they did this, they could have made a second set of parentheses here, but just to give you the reader a little bit more of a heads up that something's going on. So have 2x squared, all raised to the second power, and then raised to the second power again. So you could do this any way you want. You could work inside out, so you could do 2 squared, which is 4, and then x squared squared, which is x to the 4th, and then you go to square that one now, and then you have 4 squared, which is 16, and then x to the 4th times 2, or 4 times 2, and you got x to the 8th, and voila, number 32 is done. Alright, and there's a couple more like that. Number 33 is similar to that one. I'll let you guys try that one out. Other than that, they all look pretty decent. Something I'm not seeing on the review packet, maybe it's on at some point. Let's put another one on here. Just be careful, actually, and it is on the next packet, so there's even more practice, worksheet, and something like number 5 or 6. Notice that just the numerator, alright, so I'm on number 5 here, so just the numerator is being squared, so I'm only applying the square here, so this would give me k to the 4th, and then e squared, and the denominator does not get squared because only the numerator has the parentheses. So like number 7, if you compare this to number 7, right, both the numerator and the denominator are surrounded with parentheses, so they both get squared there. Alright, so just a little comparison between number 5 and 7, and then you have k to the 3rd, e, and then this simplifies, well, you have k to the 4th over k to the 3rd, more k's in my numerator, how many more? 1 more, e squared over e to the 1st. Again, the numerator wins, there's one more up there, and you don't ever have to write to the 1st power, so this is just ke. Alright, on this extra worksheet. Alright, and I don't know, you could play around, I guess, with 1 or 2 more, see what else is on here. This is number 15. We'll give 15 a shot. Alright, on the even more practice. So I have x to the 5th raised to the 3rd power, right? So power to the power, so that becomes x to the 15th because I'm multiplying. And then I have negative 2 to the 3rd, which means negative 2 times negative 2 times negative 2. So an odd power will keep the number negative. 2 times 2 is 4, times 2 is 8. And then y squared to the 3rd power is just y to the 6th. And there's nothing else that simplifies, and so we'll call it a day there. Alright, so we did a couple examples here. Hopefully that helps get you going here. And then during our live session, we'll work out anything else you want to work out before we move on to looking for patterns among these exponents, which is another concept we'll talk about very, very soon. Alright, talk to you guys soon. See you later.